So what I thought I might do to start off this lesson is just do a quick recap of what you learned last, which is about the quadrilateral. So there are 6 different types of quadrilaterals as listed above. We have the rectangle, the square, the rhombus, the parallelogram, the trapezium, and the kite. Now what these shapes have in common is that they all have 4 sides. They also have 4 vertices. But what can be different is that they can have different angles. So some of them will have all equal angles of 90, like the rectangle and the square. Some of them will have pairs of angles. We already know that the angles inside a triangle add up to 180 degrees. But how about a square? So we know that the interior angle sum inside a quadrilateral adds up to 360 degrees. But how do we know this? Any quadrilateral can be divided into exactly 2 triangles. And if we know that each triangle has an interior sum of 180 degrees, all we have to do is 2 times 180, which gives us 360 degrees. So for all of these quadrilaterals below, we can rule a line from corner to corner to divide them into 2 triangles, just like so. So this is our learning goal for today. I will calculate the sum of interior angles of any polygon. Now what is a polygon? A polygon is a 2D shape with straight sides joined to form a closed figure. So we can have polygons of 2 different varieties. Now polygons can be regular or irregular. A regular polygon has both sides of equal length and it also has angles of equal size. So the only regular triangle is an equilateral triangle where each side is the same length and each angle is equal to 60 degrees. Whereas a square is the only regular quadrilateral. So this doesn't include rectangles, trapeziums, and parallelograms. A square is the only quadrilateral where each side is the same length and each angle is the same size. Now a rectangle has angles that are all the same size of 90 degrees. However, its sides are not all equal in length. Therefore, it's an irregular quadrilateral. So irregular polygons include any polygon where the angles or the sides are not all equal. So we can take any polygon, and if we rule a diagonal line from one vertice to another, and we do this for each vertice that we can subdivide each polygon into a number of triangles. For example, a quadrilateral can be divided into 2 triangles, a pentagon can be divided into 3 triangles, hexagon can be divided into 4 triangles, and so on. And by doing the number of triangles multiplied by 180 degrees, we can find the interior angle sum for any polygon. Now this can be simplified to a formula. The number of vertices minus 2 times 180. So we're looking at a polygon here. Now, first of all, we need to identify what kind of polygon it is, and we can do this by counting the number of sides. So starting here from the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 sides. Now if it's a 9-sided polygon, that makes it a nonagon. Now what is the angle sum of this polygon? Well, first we can use our formula, which is n minus 2 times 180, where n is equal to the number of sides. So if it's a 9-sided polygon, therefore we do 9 minus 2 times 180, which is the same as 7 times 180, which is equal to 1260 degrees. So is it a regular polygon? And if so, how big is each angle? Well, just by looking at it, we can tell that each side is of equal length. So we can expect that each angle will be of equal size. Now, if each angle is going to be the same size, and we know that the interior angle sum is 1260, all we have to do is 1260 divided by 9, which gives us 140 degrees. So we can expect that each vertex is going to be 140 degrees. So let's do another example together. Here we got another polygon. So first of all, we need to count the number of sides so we know what polygon it is. We got 1, 2, 3, 4, 5, 6, 7, 8. So it's an 8-sided polygon, which makes it an octagon. Now, what is the angle sum of this polygon? Well, we'll start with our formula once again. We've got n minus 2 times 180, where n is equal to the number of sides, which is 8. So 8 minus 2 times 180, which is equal to 6 times 180, which gives us an interior angle sum of 1080 degrees. Now, is it a regular polygon? And if so, how big is each angle? Well, we can look at this octagon and it kind of looks like a stop sign, so it is a regular polygon. But how can we calculate the size of each angle if they're all going to be the same? We know that we got an interior angle sum of 1080. We got 8 vertices. So 1080 divided by 8 is equal to 135 degrees. So before I go through this problem, if you want to pause the video and have a chance to do it yourself and then to check your answers with mine, that'd be good. Now, first of all, what I'm going to do is to count the sides of the polygon. Now, what we have here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 sides. Now, if it's a 10-sided polygon, we call that a decagon. Now, what is the angle sum? We'll start off with our n minus 2 times 180, where n is equal to 10. So 10 minus 2 times 180 is the same as 8 times 180, which gives us an interior angle sum of 1440. Now, this is a regular polygon. So if we do 1440 divided by 10, which is our number of vertices, we'll have each angle equal to 144 degrees. So this is the last example for this video. First of all, you might notice that this polygon looks a little bit different from the others so far. And what we need to start off with is just by counting the number of sides. So I'm going to go ahead and do that now. We got 1, 2, and 3, 4, 5, and 6. So it's a 6-sided polygon, which makes it a hexagon. Now, again, we're going to use our angle sum formula. So we're going to do n minus 2 times 180. And in this case, we already know that n is equal to 6. So 6 minus 2 is equal to 4. 4 times 180 is going to give us 720 degrees. Now, is it a regular polygon? Well, it's not. We can already identify that just by the different angles that are inside it. So we got 100, we got 150, 130, and 140, and 90. Now, those aren't all equal, which makes it an irregular hexagon. But what we do know is that regardless of whether it's irregular or regular, a hexagon will always have 720 degrees as its interior angle sum. So we can work out x by simply subtracting all of the known angles that we do have. So we can subtract the 150, the 100, the 140, 130, and the 90. So when we do this, what we'll get is x is equal to 110 degrees. Okay, so this helps you understand what a polygon is and how to calculate the interior sum of angles for any polygon. And I hope that gives you a great understanding of how that rule actually works. And thank you, and I'll see you next time.